Hi, in this video, going to talk about SLAAC, Stateless Address Auto-Configuration. Okay, so this is used by both option 1 and actually option 2. Okay, it's when the A flag, the address auto-configuration flag in the router advertisement is set to 1. What it suggests to hosts is that it can create its IPv6 address automatically, dynamically. Let me show you a little bit of how it works. So the router advertisement is sent to a special a special multicast address, which is the all IPv6 devices multicast. It's sent from the router's link local address. And in this router advertisement, it contains the prefix, the network portion of the address, and a prefix length. Okay, we said the A flag is set to 1. So when a device receives this router advertisement, it says, oh, the A flag is set to 1. Okay, and you can ignore that note there, just a little note about DNS. But it also sees that the prefix is 2001 DB8 Cafe 1. So it says, okay, that's the prefix. I see the prefix length is /64. So I know what network I'm on. I know the prefix length, and it came from this link local address. Well, I'm going to use that link local address for my default gateway. It uses the source IPv6 address of the router, which is its link local addresses. This router advertisement came from a router. You're my default gateway. All right. So using the prefix and the prefix length in the router advertisement, the router now knows what network it belongs to. All it needs to do is come up with its own interface ID. And it can do that using one of two processes, something called EUI64, or just a total random 64-bit value, which is actually fine because with 64 bits, 18 quintillion possibilities, what's the chances of duplicates? But in either case, no DHCPv6 server is involved. Now, I mentioned that random. We'll talk more about that in a moment, along with the EUI64 process. So that 64-bit interface ID, okay, either can use the EUI64 process or a randomly generated number. Well, it depends on the operating system, and most operating systems will let you modify their default, but you'll see that depending on the operating system, it might use EUI64 or a random value. Now, let me just we're going to talk about EUI64 more in the next video, but EUI64 uses the Ethernet MAC address as part of the interface ID. Some people don't like that because it says, oh, wait a minute. You can now always track where this packet came from, or worse, or just as bad at least, I will always have the same IPv6 address no matter where I'm at, no matter what the network portion is. This will always be partly my MAC address. People could really start associating, what networks I'm on, what I'm doing, no matter where I'm at. So people want privacy, okay? So this value can change and be randomly generated. Now I said as a 64-bit value, that's 18 quintillion possibilities. And even with the MAC address, still 64 bits is 18 quintillion possibilities. What's the chances that either one of these could be a duplicate? Very, very slight. But just as a side note, most operating systems use something called duplicate address detection, DAD, to determine whether or not, before they use the address, whether or not it is being used. Okay, talk about that in a later video when we get into ICMP v6. Okay, so this is just a little bit on SLAAC. We'll talk about EUI64 in the upcoming video.